All right, guys, so today I wanted to talk to you a little bit about another kind of input-output table situation that you're going to see. And I'm going to refer back to my original input-output table journal entry just so I can make sure that I'm doing the steps in the right order, and just so I had that in my head of first I do this, then I do this, yada, 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 right? So I want you to go ahead and draw your input-output table. So sometimes, last time we saw it being drawn vertically, sometimes it's, horizontally, sometimes it's drawn vertically, up and down. Excuse me. So it would say like input, and then output. Okay, input and output, and then like this. So sometimes, like in our original journal entry, you know how it said number of children and feet? Sometimes it'll say it like that. Sometimes it'll literally just say input output, or I-O, right? So our numbers that we're going to fill in today are 6, 9. This one is going to be blank. Okay, blank. And then 12, and then 15. And then over here we have 18, 27, 30, 36. And then this one is also going to be blank. So sometimes you're going to encounter input-output tables where you have some missing information and then they want you to fill that information in. Well, in order to know what that information is, like in order to know what this number is and how we got to 30, I have to know that rule. Remember how we talked about this center column? I have to know how I got there, right? It's like a computer. I have to know what happens inside the computer for that number to change from a 5 to a 10. Okay, or from a 6 to a 12. I have to know what that computer is doing. And remember that we can only have one specific kind of computer at a time, correct? That's important, guys, that you understand that, that kind of table only happens, for this table, there's only going to be one rule. That's what I'm trying to say, okay? So let's go ahead and draw our double T chart. We're going to use a festive green today. All right, and remember our first step says make a double T chart and fill in the info from your table and then leave room in the middle for a rule, right? So let's come up like this. And then we've got rule in the middle. And then on the sides we have what am I looking for? We've got input. In this case, I'm just copying what's on here. So input is what would go on the left. Oh, yeah. The green is running out, so we got to find a new one. So input would be on the left. Output would be on the right. And then I'm just going to copy those numbers down, okay? So input is 6. And look how I'm doing it on each line. I'm not like 6 is really big and then 9 is really small and then I'm just going all over the page. No, you need to make this really organized because you need to make it very clear to yourself that 6 and this other number are going to be on the same line. Okay, so they're straight across from each other so you don't get mixed up and think 6 lines up with 27. Okay, very, 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 very important. So 6, 9, this is a blank with a question mark, and then 12, and then 15. Right? And then over here, 18, and then 27, and then 30, and then 36, and then a question mark. Okay? So the next step after I fill in my stuff in my T-chart is I need to look at my T-chart horizontally. Remember, horizontally is this way, right? Back and forth. Horizontally, I need to see if that first number is getting bigger or smaller as it goes through the computer, right? So 6 to 18, is that getting bigger or is that getting smaller? Well, it's getting bigger. So my two options for if the number is getting bigger is to multiply or add. So I need to write the multiplication sign and the addition sign above the rule. Okay? So I'm going to do that like this. So I'm either going to be multiplying something or I'm going to be adding something. Well, let's find out what our two options are. So if I'm going to be multiplying something, what would I be multiplying to get from 6 to 18? What has to happen inside that computer for 6 to change into 18? What has to happen for me to multiply something? 6 times what equals 18? Can I do anything 6 times anything to equal 18? Yeah, I can do 6 times 3, right? So that's one of my options. What else could I do? How could I add something to 6 to get to 18? If you didn't know this, you could do the inverse operation because you've got a whole and you got a part. You just need the other part. So let's do that. Let's do 18 minus 6. 8 minus 6 is 2. 1 minus something is 1. So I would have to add 12. Okay? So we're going to check both of these. Let's start with plus 12, and let's just see if we can add all of these inputs and have all these inputs and then add 12 and then get an output. Okay? So 6 plus 12, all right, let's see what would that equal? 18, right? Equals 18. Is this a true statement? Yes, it is. What about 9 plus 12? Let's do that over here. 12 plus 9. I always like to put the bigger one on top, right? So 2 plus 9 is 11. 1 plus 1 is 2. Uh-oh, I got 21 here, but 27 here. So this would be not equal, okay? Because at this point, I am guessing and checking to get a rule to get from one number to the other. And then I have to check that rule for all the other number pairs in the T-chart. So I did it for the first and it worked. I did it for the second one, it didn't work. So then I come down here, and if it worked, then I would have found my rule, but it did not work. Dun, dun, dun. So I have to check rule with the other operation. So this can't be it, right? It can't be plus 12. Right? So I'm going to go ahead and erase this middle part. This will happen to you a lot, okay? So you'll get to the point where you can kind of visualize the whole table and be able to figure out, well, obviously I can multiply 6 times 3 up here and whatever, but you're not at that point yet, okay? At this point, you've got to check it for every single one. Do you understand? Okay, so my other rule that I had as an option was times 3. Well, is 6 times 3 equal 18? Yeah, it does. All right, what about 9 times 3? Remember that this rule has to be the same all the way down. That's so critical that you understand that. It has to be the same, okay? So let's count by threes until we get to 9 times 3. So 3, 6, 9, 12, 15, 18, 21, 24, 27. Is that what we got here? It is. So that is a true statement. That is equal. So this one we don't know because we don't know what we're multiplying times 3, but we can check it with this number pair, right? So if I have missing numbers, then those aren't considered number pairs. So I can check 12 times 3, though. So let's actually multiply 12 times 3 using our standard algorithm method. So what's 2 times 3? 2 times 3 is 6. And so circle, 1 times 3 would be 3. Is that what we have here? 36? Yes, so that is equal. So if I've checked it with all the available number pairs and it works for every single one of those, then we're good. That means that that is in fact our rule. So now to find these missing ones, I'm going to go ahead and fill in times 3 times 3. And we know that these are going to be equal because if the rule is true for all of the number pairs, it's going to be true for the ones who have missing, like one of the pairs is missing, or one of the parts of the pair, excuse me. Excuse me. Okay, so something times 3 equals 30. Something times 3 equals 30. Well, there's a couple ways we could do this. We could do the inverse operation and say that 30 divided by 3 equals what? Or we could just count by 3s and see how many times we count by 3s before we get to 30. All right, so let's try. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. How many times did I just count by 3s? I counted by 3s 10 times. Well, what does 30 divided by 3 equal? 10, right? So this missing number is 10. 10 times 3 does equal 30. Do you agree with me? You should, because that's correct. All right, so now this is the opposite where the output is missing, not the input. So now we need to do 15 times 3 equals something else. Well, what is 15 times 3? We can figure that out right here. So it's okay if you have this extra work over here. It's better. I would rather see your work for something that you may consider, you know, easier. I'd rather see this than you just guess. Okay? So what's 5 times 3? 5 times 3 is 45. I'm sorry, 15, I just gave you the answer. 15, carry the 1. 1 times 3 is 3 plus 1 is 4. So this blank, so 15 times 3 equals 45. So this missing number is 45. So if this were a word problem, they were asking, what is this missing input number? What is this missing output number? You figured it out. All right? Okay, well, I will see you in the morning. Thank you so much for watching.